Merhaba arkadaşlar. So we will continue with chapter 7 to our discussion. Chapter 7 deals with arrays. You have already seen samples of arrays in CS 101. However, we will see some more, interesting examples that deals with loops, and in addition to that, we will see, GUI components that utilize and use these arrays and how you can use them in implementing different events and polygons and polylines at the end of the chapter. So basically, as you all know, we have an array that is declared as a set of elements, which could be primitive types such as integer, character, or could be also a set of objects such as strings or any kind of object that you define in your application. So it has a single name and it has an index that you can access for each entry of the array that you have. And if you have an array of size n, you have an index that is ranging from 0 all the way to n minus 1, in this case 10 minus 1, 9. So you should be careful with the size versus the last element in your array. So it ranges from 0 all the way to n minus 1. This is something you already know. In accessing any array element, you can represent the index that you're going to try to access within your array using a constant integer value or an expression that is going to that's going to be equal to the corresponding value, such as you could use a variable. You can perform an expression that is going to multiply a constant with a variable, and things like those you can access in various forms. So as in this example, you have an array of scores which you just get the average of scores 0 plus scores 1, and then average it by dividing it into 2, and print that out as a result of, for example, the top score that's stored in scores 5. So you can access it various forms, which again you have covered before. And as again I said earlier, you can have, instead of primitive type elements in your array, you can have objects as your array elements. So you have an array of strings, array of such as, for example, you have an object that identifies a point, array of points. If you have an object that defines, let's say, a car, so you have an array of cars. And so any type of object you can use for array description. So in scores, the way that we describe in primitive types is that for each element of the array, what you have is one entry. In this case, it's an integer value for each one of these. However, in objects, this is represented in a different fashion, right? How do we represent it in objects? If you have an object array, such as a string, since it's not a primitive type, so I have a, let's say, array of strings. When I create an array, let's say if I use string, and then let's say my string is str, string array, str, this is going to be equal to, let's say, I create a string of 10 entries. So I have new string and then 10. So how is this going to be represented in the memory? I will have my str that is going to point to these strings, right? However, these strings are actually objects, right? Did I initialize any object? Did I create any memory space for each one of these array elements yet? No, so they will be actually pointing to null addresses. So before, if you create the specific object that is going to be in this index of the array, you won't be able to access it. If you try to access, in this case, str0, you will get a null pointer exception error, which indicates that, hey, there is no object that is associated with str0. So what you have to do is that you have to create the string first, and then assign it to this str0 such that you have that object specifically. In which case, you will have a picture, something like this. So you have the string, whatever that is, in the allocated memory location, and then for the next string as well and the other string as well, so that you can access the individual objects. This is applicable to strings and also applicable to any objects of arrays you have in your implementation. So this is an important fact, and you should be careful about this. And going back to the declaration of arrays, if you remember, the way we define an array is that you give the type and then the square brackets indicating that this is going to be of type array, and then you give the name of the array and you indicate how many entries you're going to have in your array. This value must be a statically assigned value such that you reserve the sufficient space for that array. So arrays need to have a constant value so that you can declare them in a fixed location and use that fixed location for accessing those variables. There are other ways of declaring the arrays. So this is, for example, here in this case we have a float array, which is prices, and we reserve 500 floating point numbers that is going to be stored in this array. And in a similar fashion, you can just divide this declaration into two halves and just declare that flags is an array, then allocate the required space for that array later on with the new boolean 20, so that this flags will have 20 boolean values stored in this array. So for accessing the elements of an array, you can use the for each loop while you're processing the elements. This provides an easier way of accessing them. So again, scores is the array that you're going to iterate on, and the variable that is going to iterate one by one on the array is score. So you will, starting with score 0, you will process this all the way to the end of the list. If you wanted to write the version of the for loop that is going to do the same exact thing as this for each loop, how would you write it? If I wanted to write the same exact loop, but not like a for each loop, but a regular for loop. So I would say for, right? And then I will have int I, which is going to start from the first entry of my array, 0. And then I will say I less than, how am I going to, so I will say that the number of elements in my array, which is going to be stored, I will give this shortly, scores.length. In this case, length is a constant value associated with your array. So it's a public constant which is accessible. If you have the array name, you can just give the length. Note that this is not a method, so that's why I don't have these parentheses. It's rather a constant value that is associated with the scores array. So it's a publicly available constant. And then I will have I++, so that I do the same thing, system out print line. And obviously I will have, instead of the score, which actually iterates from the first array element all the way to the end, in this case I will have, what am I going to print here? Scores, right? And then I, right? So I will have scores I printed instead of writing it and using it for each loop. So again, it starts from the lowest index, which is 0, and goes all the way to the highest index of the application of the for loop. So let's go into the basic array.java example. So this is basic array example, and if you look into the main method, we have a constant limit 15 and then multiple 10, and you create an integer array limit which is going to store 15 number of integers in your array, right? And you reserve the space for that. Next thing is you initialize all the array values. So you start with index 0 and then go all the way to the limit, which is the size of your array, and index ++. List index arrays that entry starting with the first and going all the way to the end. What is it going to assign to the integer value for the corresponding element? It will just take the index value. If it is 0, it will take 0. If it is 1, it will be 1. And then multiply it with multiple, which is 10. So for each entry, you will have 0, 10, 20, 30, 40, and so on, right? So it will just get the index value and then multiply it by 10. And there's just a small update, change one of the values. List 5 is updated to a new value, and then you have the for each loop which goes among the list starting from the first index, which indicates the value, and then you print the value so that with the iterator you can print things on the screen. Basically this is just going to print everything on the screen one after the other one. So if you go and check the output of this code, as you see, it starts with 0, 10, 20, and then goes all the way to 140. Since you have 15 elements, it starts with 0 and then goes all the way to 14 and multiplied by 10 every time. And the fifth, actually the sixth entry, which is 5, you know, the one that is indicated by index 5 is going to be updated to 999. Any question? This is a basic array implementation. Bounds, you know, this is also important. You have to be careful with the bounds of the array. If you go and access an array an index of an array that doesn't exist, you'll get an array index out of bounds exception. This usually happens at the end of the array, or if you don't have a control in accessing the index of the array, that can also happen. For example, if you go beyond any of this range, if you go negative values or values that are greater than n-1, you'll get an array index out of bounds exception. This usually happens with the n, where you think that you have 15 elements, and then you just go all the way to the 15th entry and try to access it. However, since it starts with 0, you can go only up to 14, so you have to stop there, and that's what usually you see as an array index out of bounds exception, and that's something you want to be careful about. So for example, in this given example, you see that this is an array of 100 elements, which goes from 0 all the way to 99. However, in this example, as you see, there's a problem, which is, where's the problem in this example? So you try to access the codes 100, which is because you have less than or equal sign, and this will be a problem, and you'll get an error, right? So trying to access this element would create a problem for your bounds, and you want to avoid this. So as I said before, you have the length constant, which is a public constant. When you create an array, it is also created. So this constant actually indicates the number of elements that you have in your array, and you can access it by scores.length or whatever the array name .length will give you that. So let's look into reverse order example. Reverse order, and then I have letter count. So the size of the array, initially it tells you the size of the array, which is going to be 10. So you'll enter 10 numbers here. So I'll just enter it in the same order: 4, 5, 6, 7, 8, 9, and 10. So basically what it does is that the numbers in reverse order: 10, 9, 8, 7, and then goes all the way to 1. So how do you think I can write this code? So basically what happens is that in the code, what you have is you ask for the user to enter 10 different numbers, which is the size of the initial array. So you take with a loop, starting from 1 all the way to 10, you get the user input, and you must store them somewhere, right? Because it is printing the numbers that I entered in the reverse order. So you must have an array that you're going to store these values in, right? And then how are you going to write them on the screen in the reverse order? Actually, maybe I should have written the numbers in a different fashion. What this is doing actually is not sorting at all. It is just writing the numbers in the reverse order then entered. So there's no sorting involved in this. Okay, so let me run again so that this will be more clear. So I will just say 4, 5, 2, or 52 anyway, 6, 3, 9, 0, 1, 7, 13, and 5. So it's just basically reversing the order of values, printing them in the reverse order. So 5 is printed first, then 13, then 7, then 1, and so on. So there's no sorting involved at all.
You'll be having a for loop which goes from
Yeah, it's basically simple, right? You'll just store them in the array from the first entry all the way to the end, and then when you're printing, you'll just write the loop such that you start with, right, for I equals, in this case, the length of the array, or 10, whatever you choose. So you'll go with, let's say this is, again, stored in scores. You will start with for scores dot length -1, right? So I will start with the, if I have 10, I will start with 9th entry. And then I will say I is, so I will go all the way to 0, right? Which is going to be indicated by greater than or equal 0, right? And every time I will just subtract 1 from my index value. And you can just, write it using the scores I, so that it will start with the last entry and go all the way to the first entry. So basically this should be the code that is performing this task. And when you look into this, it defines the array, double array numbers, and allocates 10 entries, so it's going to have space for that. And then the size of the array is printed. So if you remember, we had the 10 indicating the size of the array at the beginning. And for each element, it's asking enter number index +1. The reason, again, having index +1 is that since our index goes from 0 to 9, whereas the number is from 1st to 10th. So it's just using that convention. Why do I have parentheses here? So if I what happened? So it's basically concatenating the values as if it's a string, right? So it uses 0 plus 1, so it concatenates 0, then 1. And then 1, again 1, 2, again 1. So basically it's not doing the math, but rather actually concatenating the string. So to perform this first, the addition, before concatenating, you have to use the parentheses indicating that, you have this calculation first and then concatenate the value. That's why you have the parentheses. And every time you read the next value, you copy it to the corresponding array location. And once you read all the values, the next thing is printing them on the screen. So you have index that is going to be from the length -1, as we did before. Index goes until it's greater than or equal to 0, and we subtract 1 every time and print that on the screen. Any question? So this is reverse order, which is a basic example. And there's also letter count example. Again, let me compile and execute this. So enter a sentence. So I love CS102. As you can see, after this text is entered, it lists the number of characters on each letter. So A, B, C, since I have one C, one capital C, it shows 1. And then one I, it shows 1. And one S, blah, blah. And then you have love for all those letters, you have 1. And then it also indicates non-alphabetic characters. It counts those, such as the spaces and 102, which makes 5 characters. So you have non-alphabetic characters as 5. So how do you think you can write this code? Basically, the first idea you need to keep in mind is that you have to read letters one by one, right, from the entered keys. And then from that point on, you have to somehow store the information that you count so far. So if you have letter A, you need to count them one after the other one, and you need to keep it somewhere in order to print it. The easiest way to do is, since you have 26 different options, to have an array of 26 elements in it, which is just going to be integers to count the corresponding character, right? So I will have an array that indicates the number of characters in my string for the capital letters, and then for the lowercase letters a separate array. Or you could combine those two arrays if you want to. However, to be clear, you can have a lowercase array and then uppercase array and count the letters one by one. How can you count them? So if I see, so you will, as one of your friends said, you can use the char at, right, to indicate the current position, and let's say if it is I, if I have a letter capital A, let's say, which entry of the array should I increment by 1? If this is, let's say, upper, I keep track of my count in the upper array. I will use the upper array, right? So upper 0 will indicate capital A. So to check which counter I will increment, what do I need to do? If you consider upper 1, what is this? This is capital B. So how can I get this index value? 0, 1, 2. How can I get that? You need to, since your base is capital A, if you subtract the character from capital A, you should be able to get the index of the array element. Such as, for example, what's the value of B minus A? It's equal to 1, right? Because it's 1 after A. So as you can see, you get that position in the array 1. If you have C, if you subtract A from C, you can get the corresponding counter for the capital C. So this is something you can use in accessing the corresponding index and increment it. For A, it is going to be A minus A, so you will access the 0, right? So that's the way to implement this. And let's see the code. So letter count, basically you have the number of characters 26, since you have 26 letters, and you have the scanner defined here. And I have two arrays, upper and lower, which indicates the counters for uppercase and lowercase, right? And then I have the char current, which is just basically the current character I'm reading. And then other, it indicates the counter for non-alphabetic characters, such as space or numbers. So it will start with 0. And enter a sentence, you read the line from the user. Then what you do, this is basically the loop that checks for that. So it goes from the first entry and then goes all the way to the end of the string, line.length. Remember, this length is a method, so that's why I have the parentheses in this string method. It's a string library method which you use for the length. And every time I get the character at the current position. In our case, what you do is that you have, I love CS102. So it initially points to the first character at position 0. If this character is greater than capital A and it's also smaller than or equal to capital Z, then that's an uppercase letter. So I will update the corresponding index of my array. So I will go and update upper current, so whatever that character is, in this case I minus A, whatever that value is, going to be my index for updating my counter. So it will be, instead of 0, it will become 1. Right? Do you understand the logic behind this? So you get the character minus whatever that is in the example I gave you. If it is B, it will be B minus A, so that it will become 1, so that you access upper 1 and update the corresponding value for the counter. And if it is not a uppercase letter, however, if it's a lowercase letter, you come into this part and you check whether it's between lowercase n and lowercase z. If it is the case, you again subtract current from the lowercase a. Same thing, however, you update the lower array and increment the value by 1. If none of these, if it is not alphabetic character, then you increment your other counter by 1, indicating that it's not an alphabetic character. At the end, how you print them, this is where we print those. So we have character, letter, plus a. So letter is changing from 0 all the way to the end of the length of the upper. So which is going to be 26, right? Upper's length is 26. And you will update, you will print on the screen. What are you going to print? What is this going to print? So it's going to basically print those ABCs on the left hand side. This A will be printed first. Why is it printed A? Since your letter is 0, it will add the ASCII character of A, capital A, which is 65, right? So it will add capital A 65 to 0, and then it will make 65, and the corresponding character casted to character is going to be again capital A, right? And then if you have 1 as letter, it is going to print 65 plus 1, 66, casted to the character, which is going to convert it to the ASCII character, which is capital B. So on each line, it's going to write the corresponding capital A, and then it is value, whatever that count is. And similarly, you print the lowercase a and its lowercase count printed next. So if you go into here, you see that this is the first line. So you add 0 to capital A and print that, and the count that is indicated by that. And lowercase a plus 0, so it will make lowercase a again, and print 0 and go into the next line until you reach 26. And at the end, obviously, you print the non-alphabetic characters by a print line statement and printing the other integer value. Any question? So in Java, you can represent arrays using both of these methods. So you can have float array prices or float prices array, which will both mean the same thing. However, usually the convention is to use this type of representation. So this is more meaningful and more readable compared to the other one. But if you choose to use the other one, that's also possible. Initializer lists, if you have an initialization of multiple items at once at the beginning, some values that you already know, you can immediately identify and assign those to your array, as in this example. So you declare int units, int array units, in which case it's going to have these values stored in the array. So in this case, the size of the array is already specified by the number of elements that you assigned here. So in this case, you have a length of 10, right? So since you have 10 entries, the array will have 10 elements, and there is no other new or declaration that indicates how many entries you will have in the array. So this is the only place that you assign these elements and initialize them, instantiate them at the beginning of the declaration. So this is only done at the declaration phase. Also, you can do it with the characters, where you assign those characters to the array. When an initializer list is used, the new operator is not used, as I mentioned, and then there's no size value specified at the beginning. It is based on the number of entries you have in your initializer. So let's see the primes.java example. So basically you have int array prime numbers, and then you have the numbers listed for first couple of prime numbers, and this is just having a for each loop which prints all these prime numbers one after the other one. So basically it's showing this declaration here. So arrays as parameters. As any object, you can pass arrays as parameters to your methods. Then what's going to happen with the arrays? If you pass as an argument, how are they going to behave? So if you recall, in primitive types, whenever I pass an argument as a primitive type, what happens is that you just copy the value of that variable into the formal parameters, such as, let's say, if I have a method call count with an integer I, what happens here? You just copy the value of the passed argument into the variable, the formal variable that you have, right? However, in objects, what happens, such as the example that we have shown before, if you have number f1, which is an object, then in that case you actually pass a reference to that object specifically. So they become the aliases of the same object. In the example, if you remember, in the previous lecture we had this A1 that was referring to number, and then we were calling this with, let's say, count A1, and in this case it's going to be, let's say, count 1 A1. In this case, what happens is that F1 also points to the same object, right? They become their one another's aliases. So this is the object's point of view. What happens with arrays? If I pass arrays as arguments, what's going to happen to my array? How is it going to behave? Is it going to behave as if it's a primitive type or as if it's an object? It's going to behave like an object, right? So you will basically passing a reference to the array also. If you update the array elements, the corresponding original array pointer or original array elements will also be updated according to that. So you can use, you need to be careful with that type of implementation. So the reference will be updated according to your modifications. So as I said earlier, you can also use objects in your arrays. So arrays of objects is also possible. So whenever you say string array words, new string 5, it actually allocates an array that's going to store 5 different strings. However, those strings are not initialized at the beginning. They are not created at the beginning. Unless you define and initialize them, they will be just null pointers initially, as in this example. So they won't have any value that is stored with those. And you'll get null pointer exception if you happen to write something like this to access word 0. So this is different than primitive type implementation. And whenever you initialize those strings, you will get these objects, that are referring to the individual words 0, words 1, and words 2, and so on. So you can also create, arrays of objects using the initializer, such as this one. So you create string arrays, verbs, which is going to be, the first verbs 0 will be play, verbs 1 will be work, and so on. So you can initialize the values of an array by using the initializer, as we did with the integer values. So if you have objects that you need to create, you can do that too. Let's see the grade range and grade.java. So when you look into the grade, it's a class, it's a class that is having two instance variables. One is the name of the grade range, and then the other one is the lower bound that is associated with the corresponding grade range. And when you look into the constructor, basically it just has only one constructor, which takes the grade range as a string and then the cutoff point, so it will assign the corresponding instance variable, as you can expect. And then it has a two-string method, set name, set lower bound, get name, and get lower bound. These are, implemented as getter and setter methods for the grade class. This is basically having two, instance variables for each grade object. And when you look into the grade range, the grade range in the main class has an initializer which has a grade array that's named as grades, and this array is initialized with 12 entries. So when you look into this, it basically creates grade objects one after the other one and then puts them into the corresponding positions. So new grade, since this is the constructor with the two arguments, the string, which is the name of the grade, and then the cutoff point, and then you have the second grade A minus and then the cutoff point, and so on, so that your array will have all these grade objects stored in the array. It is just an association. It depends how you interpret it, but for this class, it only has a meaning that says, hey, this grade range's name is A minus, and then the integer value that's kept as part of the object is 90. It doesn't mean that it has to be between 90 or 95 or anything like that. It only may, make sense if you do implement it within the class methods. But, basically in the base case, if you go into the grade.java file, you see that it is only these instance variables, and then you have the constructor, toString, setters, and getters. That's all. So there's no, correlation between this class or that class, that object or that object. So there's no correlation at all. You could say, you can give another, C plus, and then say the lower bound as 90. So it doesn't mean anything. It's just a class that they came up with, and you can just use it as an array in this example. So it doesn't have an inherent meaning between those ranges. And in the last part, it just prints with a for each array. It prints the individual letter grade on the screen using the toString method of the grade. So it's just going to be calling the grade.java's toString method, which will basically print the name of the grade, and then with a tab, after the tab, it will have the lower bound associated with that grade. Okay. And also, there's another example which is dealing with the CD collection. So this is more interesting. So we have tunes, and then CD collection. So if you look into this one, we see that they have defined a CD class, which in each object you have the following instance variables: the title of the CD, artist of the CD, you have the cost of CD, and the number of tracks in the CD. So these are the instance variables. And obviously you have the constructor with all these arguments passed and created when new object is created. And it has the toString method, which basically prints for each CD object the corresponding entries, such as the cost, the number of tracks, and then the title and artist followed one after the other one with a tab between. Right? So this is basically the toString method, which will be called if it is written on the screen or used as a system out print line. And when you look into the CD collection.java, you see that the relationships get complicated with arrays. In this case, you have a CD collection which has a instance variable which is a CD array. So the collection is going to be the CD array, array of CDs, and you have a count that keeps track of the number of CDs you have in your CD collection, and then the total cost keeps track of the total cost of the all CDs you have in your collection. So when you call the constructor, what you see is that it creates an array and allocates a space for CDs of 100, right? So you have 100 CDs that you can store. And the count is equal to 0 since there are no CDs yet. And then you have a total cost of 0 initially. This is the constructor. And whenever it's created, this will be called. And when you add a CD, so you can add CDs onto your collection, what does it do? This part I'm just going to skip for now. What does it do? It assigns the next collection, the next position of the collection to the new CD that you just want to add. So it will create the CD, new CD with title, artist, cost, and tracks, and assign it to the array element that is the next one that's empty. So why is it having the index count? Remember, count keeps track of how many CDs I have so far. So initially it has 0 CDs, right? So it will have an array of 100 CDs initially, right? And then my count initially points to count is equal to 0. So it will point to this. Since there are no CDs, it will be able to access this one and then create this CD and have it point to that specific CD that I just created with the new command. And then I increment the cost and update the count. Now my count becomes 1. So whenever I add a new CD, what will I do? I will use this new index to indicate this position, because I know that I have 0 to count minus 1 already filled in, right? And then since I have count number of CDs so far, this is already filled. The next thing I need to continue is the count, right? So that's why you use count as your new CD adding position. So I create this new CD and add it to that position, and my count becomes 2, such that since I have 2 CDs so far, I can create the next CD onto this count 2 position, which will give me the next CD in the sequence. And coming back to here, as you see, once I reach the collection length, which was originally 100, right? What's going to happen? It will increase size. Why is it doing that? Because you're already, if you reached 100 entries, which will range from 0 all the way to 99, you have all CDs stored in here. So what you need to do is you need additional space to store this, which is going to be done by increased size. So how can I do increase? How can I increase the size? Exactly. So what I need to do is, since this space is already filled in, what I will do is I will create a new array with possibly more locations that are available. Usually doubling the size is the methodology used. So instead of 100, I will have 200 elements in this CD, this new CD collection, the array, right? And what am I going to do? I will call this, for example, temp, and then this is collection, remember, which has 100 CDs on it. And I create this new temporary CD collection. That's an array of CDs. And then what will I do? I'll just copy the entries of this onto this one. So I will just copy this pointer so that I will have this pointing to the same CD. And then the next one will point to the same as the second one. And then this one will point to the same thing, and so on. So all of them will match to the corresponding entries. So I will have the first 100 CDs filled in, and the rest will be empty, right? And the next thing is what I will do is that I will call this temp as a collection, since I keep track of things in collection. Now my collection will become something like this, will be sufficient to do this. And then my temp will become collection, because I already copied things. I don't need to keep track of this anymore, and I can just rename this as collection so that I keep track of my collection in this new array. So if you go and see the increase size method, it will be more clear. This is the temporary array which we create, array of CDs, the name is temp, and then you get the new, allocate the space for the new CD array, which is going to be collections current length times 2, so that I have sufficient space. And I will have, starting from the first entry, I will copy the collections current, the ones that are currently pointing into the temporary one, so that I make this assignment. Temp CD equals collection CD. And once I copy all of them, one after the other one, I will say, hey, I can now use collection instead of the temp there. And this will do the job and perform the copying operation. Okay, any question? Let's give a break and I will continue from this point on and we will continue.